Good morning, students. We are going to continue our work on completing the squares today, and I am looking to blow your minds. That's right. I'm going to blow your mind today. At least I hope to. Let's go to work. We are looking at the homework from, what day was this, 2 days ago? From Monday. This was our first completing the square homework. It was a 2-pager. So this is what you would want to be looking at. And I want to jump down to number 9 and number 10. We've already dealt with the first few. Those are just part of completing the square. And we're down here at starting at 9 and 10, and we're looking at these ones where we've already completed the square. So if we look at number 9, we were originally given x squared plus 12x plus 35, and we took our 12 and divided it by 2 and saw that was 6, and we added squared it, and then we added 36 and subtracted 36. We went through that whole process, which is right here, about completing the square, and we found our completed square is now x plus 6 quantity squared minus 1 equals 0. Now, that's the Vertex form, and that's what we were trying to do when we did this homework. However, what I want you to realize is we did not follow the directions so far. We did not follow directions. The direction says solve each equation by completing the square. We completed the square, and when we complete the square, what can we see? That's right, the vertex. So what is my vertex of this particular problem? Anybody? Not 6, -1, -6, -1. Remember, we got to take the opposite of what's on the inside. Remember, those parentheses, man, they mess with us. Anything that's on the inside of the parentheses always, as we take it out, when we're talking about these quadratics, it ends up being opposite what we subtract, what we said. No matter what. Remember, because our formula for vertex form was f of x equals a times x minus h quantity squared plus k. And this minus sign, sometimes we read it as opposite. So we need the opposite of what we see in there. Okay. Looking at number 10, what is the vertex then? 8, -4. Now we can see that really quick and easy, but that's not a solution. That's the vertex. What are our solutions to quadratics? Well, they are the points where they cross the x-axis. Let's see. The solution is also known as the roots, the zeros, the x-intercepts. Okay? Well, this doesn't tell us the x-intercepts or the zeros or the roots. It tells us where the vertex is. But we can still manipulate this a little bit further and find the solutions. Now, several people ask me in this particular worksheet, hey, we always had plus or minus a square root at the end. Is that always going to be the case? No, it's not always going to be the case. So these numbers aren't always going to be pretty like these ones we're going to deal with today. But I want to show you the process. So here's what happens. Let me really get into number 9 here. Okay, and I'm left with this one that's in vertex form. If I want to solve this, here's what I got to do. I got to start by taking this to the other side. So how do I take that to the other side? I do the inverse. So it's -1, so the inverse would be +1. Whatever I do to one side, got to do the other. So I'm now left with x plus 6 quantity squared equals 1. Okay. We're just thinking regular equations here. What would I do to solve this? I have to undo that square. How do we undo a square? Square root. Whatever I do to one side, I got to do the other. Now, when I take that square root, that'll cancel this. And all I'll be left with on the inside is going to be x plus 6 equals, and what's the square root of 1? Yeah. What's the square root of 1? Yes, it's 1, but it's also a -1. So it's a plus or a -1. So there's two solutions. There's two solutions. Well, that's cool because there's usually two solutions, aren't there? Yeah, there are. So This is going to be a plus or a minus 1. Plus or minus, that little sign right there is just a shorthand of me saying a positive 1 or a negative 1. You understand that? Okay, so I'm still not done. Now what do I have to do? I got to subtract 6 from both sides. So x equals positive 1 minus 6. Negative 5. Or negative 1 minus 6. Negative 7. Cool? Kinda. I'm going to come back to this and show you something else in a little while. And that's when your mind will probably go. All right, let's look at number 10. Look at number 10. If I'm going to solve this, I'm going to add 4 to both sides. And so I now have p minus 8 equals 4. Oops, p minus 8 quantity squared. Now what? Take the square root. Take square root. P minus 8 equals plus or minus 4. Now I have to add 8 to both sides. So P equals positive 4 plus 8 is 12. Negative 4 plus 8 or 4. 12 or 4. Cool? All right, now's where I got you. You have to write down a couple notes. Okay? Need you to write down a couple notes. You're going to learn something really big right here. A fundamental theorem of algebra in layman's terms. Okay, the fundamental theorem of algebra. The degree tells you the number of possible solutions. The degree tells you the number of possible solutions. So, if I were talking about a linear equation, how many possible solutions does a linear equation have? 1. Why? Because it's to the first degree. How about a quadratic? How about a cubic? How about a quartic? It has 4. Linear equations to the first degree has 1 possible solution. The quadratic equation is to the second degree. It has 2 possible solutions. A cubic equation is to the third degree. It has 3 possible solutions. A quartic is to the fourth degree. It has 4 possible solutions. Now, I say possible because it could have less. For example, have we ever had an equation, a linear equation that had no solution? Yeah, we've had that. Okay, now I want to give you another example. This is a graph, and this is a parabola on that graph. How many solutions does that parabola have? Why 2, Leo? Very good. How about this parabola? Only has 1 solution because it only touches it 1 time. How about this parabola? No real solutions because it never crosses the x-axis. Hey, so what you're telling me is that the solution, no matter what kind of equation I'm given, the solutions, in air quotes, the solutions are where the graph crosses the x-axis? Yes, always. That's why they're always called solutions or zeros or roots or x-intercepts. Okay, that's cool. Well, since I said that, what if I talked about a linear equation? Could I have a linear equation that looks like this? How many solutions would it have? One. Could I have a linear equation that looks like this? How many equations or how many solutions does it have? None. No solutions, right? Let's go to a cubic. I could have a cubic equation that could look like this. That's what a cubic equation looks like, by the way, graphed. How many solutions does it have? Three. It crosses 3 times. But I could also have a cubic solution that could look like this. How many solutions would it have? You understand? Could it have 2? Not this particular one, but could I have one that has only 2? What would it look like? Could look like this. It could cross once, touch, and go like that. It's snowing. Imagine that. All right. One more. How about a quartic? Watch this. Watch this. Here's a quartic. How many solutions does that have? 4. Could I have a quartic that looks like this? How many solutions does it have? Could I have a quartic that looks like this? How many solutions does it have? This is the fundamental theorem of algebra. It says whatever your degree is, that's the total number of possible solutions you can have. Cool? So we're dealing with quadratics. So we always got to be looking for how many solutions? 2. Okay, we're always looking for 2 solutions. So let's get back to this process. Let's look at number 11. This is, we've taken an equation that was in standard form. We have manipulated it to put it into vertex form. And once it's in vertex form, I can use my property of square roots to solve. So I add 36 to both sides. And I have p plus 3 quantity squared equals now 36. Take the square root of both sides. And I end up with p plus 3 equals plus or minus 6. Minus 3, minus 3. So p equals positive 6 minus 3 is 3. Negative 6 minus 3 is a negative 9. We got this? I want you to try number 12 on your own. I'll give you a minute. All right. Number 12, we're going to have to add 9 to both sides. So I'm left with x plus 4 quantity squared equals 9. Take the square root of both sides. X plus 4 equals plus or minus 3. Subtract 4 from both sides. X equals a positive 3 minus 4 is a negative 1. Negative 3 minus 4 is negative 7. By show of hands, how many people got that? Those of you who didn't. Questions? Let's look at the next one. Equals 0. Okay. First thing I'm doing is I'm getting this by itself. Okay. So I have to add 16 to both sides. In other words, I'm just moving this over here. But anytime we move something across the equal sign, we have to do the inverse. So I'm left with b minus 10 quantity squared equals 16. Okay. Now I'm essentially trying to get that b by itself. Solving equations just like we've always done. All right. But that thing's inside a parenthesis that's squared. How do you undo a square? Square root. Okay. Now, time out. What's the square root of x squared? X. What's the square root of 6 plus 2 squared? 6 plus 2. Like, anytime you take the square root of something that's squared, you get the something underneath. Does that make sense? Okay. So if that makes sense, when I take the square root on the left here, I end up with b minus 10. And when I take the square root of 16, what number times itself gets me 16? 4. But also negative 4. What's negative 4 times negative 4? Not a negative 16. It's a positive 16. So there are two solutions to this. Does that make sense? So instead of writing it like this, I just have been writing it plus or minus 4. And I know that messes with some people. So let me leave it like this here. 4 or negative 4. Are you with? Now I'm still trying to get the b by itself. So it's b minus 10. I now have to add 10. But I have to do it to both sides. So I have to go 4 plus 10. And I have to go negative 4 plus 10. Well, 4 plus 10 is 14. And negative 4 plus 10 is 6. So my solutions are 14 or 6. Now I want to get crazy here. I want to get crazy. Yeah, it's time. Let's look at this problem. First of all, what's my... let's not do that one. Let's go back to... this one. We okay with this right here? Sure. There's my vertex. And there's my solutions. Yes? Watch this. Everybody with me? There's my vertex. And there's my solutions. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. What's my vertex? Negative 4, negative 9. About right there. Yes? What are my solutions? Negative 1 and 5, 6, 7, and negative 7. Isn't that cool? Huh? Exciting stuff, huh? Exciting stuff. Let's look at number 14. 14. All right, let's start by solving it. What's the first thing I'm going to do? Add 121 to both sides. So I have r minus 8 quantity squared equals 121. Now what? Ryan, square root of both sides. So I'm left with r minus 8 equals, what's it equal? 11 or negative 11, right? Am I done? Now what do I have to do? Althea? I already did the square root. Taylor? Add 8 plus 8 plus 8 plus 8, right? So it cancels here. 11 plus 8 is 19, or negative 11 plus 8 is negative 3. Those are my two solutions. Those are the two places where it's going to cross the x-axis. All right, I'm going to blow your mind again on number 15, but I'm going to give you a minute to solve 15 by yourself. Go. All right, number 15. Who can walk me through step by step? All right, Zyler.
So first you add 4 both sides.
Plus 4, plus 4, n plus 9, quantity squared, equals 4.
And you take the square root.
Take the square root of both sides, okay? So n plus 9 equals positive or negative 4. Is everybody okay now with me writing it plus or minus 4? Is there anybody struggling with that? Okay, that's two numbers sitting there. I just write it a little simpler. All right, go ahead.
And then you subtract both sides.
Minus 9, minus 9. So n equals a positive 4 minus 9 is a negative 5, and a negative 4 minus 9 is a negative 13. Cool?
I thought the number was 64 instead of 4.
Oh, is it?
Yeah.
Okay. I must have like bumped it, huh? So let me put that 6 back, and then I have to do all this work all over again. Why do you guys tell me before? Wait, get all the way through.
Well, at least we got all of the steps and stuff. Another steps not.
Let's try again.
Add 6.
Add 64 both sides. So n plus 9 quantity squared equals 64. Take the square root of both sides. N plus 9 equals plus or minus 8. Minus 9, minus 9. N equals 8 minus 9 is a negative 1. Or negative 8 minus 9 is a negative 17. With me? Am I good? All right, let's get crazy. What is the vertex? Negative 9, negative 64. Okay, negative 9, negative 64. So it's going to be way, 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 way down here somewhere, right? Where it's going to cross the x-axis at negative 17 and at negative 1. Pretty cool, huh?
Where's the 9?
Doesn't. I mean, it was subtracted.
How do you pick your minimum?
Huh?
What number do you use for the minimum?
The minimum would be negative 64. The value of the function at that point. We good? Let's try number 16. Do number 16, please. I'll give you a minute. All right. Who can walk me through this one? Mendoza, go ahead. Walk me through it. Plus 25, plus 25. So V plus 8 quantity squared equals 25. Square root both sides. So V plus 8 equals plus or minus 5. Minus 8. Minus 8. So V equals 5 minus 8 is negative 3. Negative 5 minus 8 is negative 13. Cool? Quickly. The vertex will be negative 8, negative 25. And then it'll cross at negative 3 and negative 13. Cool? So now that we've put it in vertex form and solved it, we can find our 3 most important things. The vertex and the roots. Isn't that cool? Isn't that cool? I want you to do 17 and 18 this time. 17 and 18. $17. Start by adding 4 to both sides. So x plus 10, quantity squared, equals 4. Take the square root of both sides. So x plus 10 equals a positive or a negative 4. Minus 10, minus 10. So x equals 4 minus 10 is a negative 6. Negative 4 minus 10 is a negative 14. Yes, absolutely. Again, you just let me be an idiot. Sorry. Let's try it again. Negative 2 minus 10 is a negative 8 or negative 12. How's that? That better? How many people got that by show of hands? Good. Almost everyone. Almost everyone. Number 18. Plus 9. Plus 9. That was ugly. So R plus 1 quantity squared equals 9. Square root of both sides. R plus 1 equals plus or minus 3. Did I get it right this time? Okay. Minus 1, minus 1. R equals 3 minus 1 is 2, or negative 3 minus 1 is a negative 4. Now, who can tell me what's my vertex? Negative 1, negative 9. So if I were to graph that, negative 1, 9, negative 9. There's my vertex. And it's going to cross at negative 4 and 2. Woohoo! Do the last 2. And do a rough graph, too. And do a rough graph. All right. Number 19. Leo, walk me through it. Add 64 to both sides. So I have x plus 6, quantity squared, equals 64. Square root both sides. So x plus 6 equals plus or minus 8. Minus 6. So x equals 8 minus 6 is 2. Negative 8 minus 6 is a negative 14. If I were to sketch a rough graph, it's going to be, my vertex is going to be negative 6, negative 64. So it's going to be way down here at negative 6, negative 64. And it's going to cross at 2 and 14. Or 2 and negative 14. How many people had that? Excellent. Excellent. Last one. Last one. Who can walk me through this? Emily. All right.
So you add 14 to
Add 144 to both sides. It's okay. I make the same mistake. Makes me feel good. That was nice of you to do that for me. Thank you. M plus 10 quantity squared equals 144. Square root of both sides. So M plus 10 equals plus or minus 12, which is the square root of 144. At this point, how many people get to this point and like, I don't know. What are we trying to get by itself? M. So what's with the M? So you got to get rid of that. So what are we doing, Emily? There we go. Minus 10. Minus 10. So M equals 12 minus 10 is 2. Negative 12 minus 10 is negative 22. What was my vertex? Negative 10, negative 144. Ooh, that's really, really down there, isn't it? Oops. Thank you. Negative 10, negative 144 is way down here somewhere. Then it's going to cross at 2 and negative 22, which is going to be out here somewhere. What do you think? Mind blown? You know what's really crazy? Is how later I'm going to show you how this is a transformation as well. Can I get a woo woo? All right. Hope you all had a good lesson. Have a great day.